Until we fully understand those first moments, we should not assume any special reason for their values.
When we trace cosmic history back towards the so-called Big Bang, as we get closer to the very beginning, we become more and more uncertain. That's because conditions then become more extreme. We lose our foothold in experiment because conditions are more extreme than we can simulate or achieve in any experiment on Earth. So there are great uncertainties.
For a while, mainstream cosmologists were content that once we understood better the underlying reason for the laws being set as they are, fine-tuning would no longer seem so mystical and would once again fall within the realms of physics and mathematics.
The general view of this, for most physicists, is that these fine-tunings are largely accidental, that the constants of nature are determined by some mathematical principles which have nothing whatever to do with our existence. Impersonal, mathematical, and we were just incredibly lucky that that mathematics happened to give rise to a universe with all this kind of fine-tuning.
And so the anthropic principle existed as an interesting but eccentric theory. But then, quite unexpectedly, a completely new law of nature was discovered, and our universe relied on this law being so precisely tuned that it seemed no rational theory would ever explain it.
Our universe seems to be defined by a set of numbers which in some sense look special. If we had different numbers, we would end up with a sterile universe. People react to this seeming coincidence in a number of ways. You could say it's the outcome of some kind of design or providence. We could say it's a brute fact we have to accept, because these numbers might be determined by some theory which we haven't yet discovered.
For a while it was possible to believe that the laws of nature were not so precisely set as to require the hand of a creator. But then a completely new fundamental property of the universe was discovered. An anti-gravity force present in space itself. It is called the cosmological constant, and when cosmologists calculated its effect on the evolution of the universe, they realized it had to be very finely tuned indeed.
The fine-tunings, how fine-tuned are they? Most of them are 1% sort of things. In other words, if a thing is 1% different, everything is bad. And a physicist could say, maybe those are just... On the other hand, this cosmological constant is tuned to 1 part in 1020, 120 decimal places. Nobody thinks that's accidental. That is not a reasonable idea, that something is tuned to 120 decimal places just by accident. That's the most extreme example of fine-tuning.
No force in the history of cosmology has ever been discovered to be that finely tuned. The cosmological constant needs to be set to 1 part in a trillion, 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 trillion. Otherwise the universe would be so drastically different that it would be impossible for us to evolve. That the cosmological constant arrived at such a tiny value by chance seemed to be out of the question, but the alternative explanation was also impossible to contemplate.
Physicists did not want to accept the idea that the laws of nature might be controlled by well, the benevolence of nature. There should be no reason why the luck should just have it that we can exist. It's too much, it's a stretch. It's much too far to stretch.
It seemed that hidden in the laws of nature was a value so precise that it was impossible to deny that our universe was designed. But a designed universe requires the existence of a designer, a notion that even the anthropic scientists did not want to entertain.
There's some people who love mystery and really enjoy not having all the answers. And then there are other people who fear mystery and uncertainty and just want all the answers and to get on with it. And they will be delighted if you give them a little book, you know, whether it be Mao's Little Red One or some particular religious book that says, here's all the answers, okay, now go off to work and don't worry about this anymore, it's all taken care of. Many people find a certain security and solace in that.
The scientists were between a rock and a... Their own discoveries were pointing them towards an intelligent designer.
This is its dislike of mixing religion into physics. I think they were somewhat afraid that if it was admitted that the reason the world is the way it is has to do with our own existence, that could be hijacked by the creationists, by the intelligent designers. And of course what they would say is, yes, we always told you so. There is a benevolent somebody way up high in the universe who created the universe exactly so that we could live. I think physicists shrank at the idea of getting involved in such things.
Some people say that this apparent fine-tuning of the universe is a brute fact. We wouldn't be here to worry about the issue otherwise, and that's the way things are. Others are a bit more perplexed and invoke providence or a creator to explain that things were set up with the aim of producing a complex universe. Some people are satisfied with a religious explanation, whereas I think it is a scientific question which deserves to be addressed by cosmologists.
And cosmologists have found a solution to the fine-tuning problem. It is simple and elegant, but it requires a leap of faith as profound as any religious belief. If our planet is not alone, if it is one of billions of planets, orbiting billions of stars in hundreds of billions of galaxies inside our universe, could our universe also be one of many?
It may turn out that our concept of the universe, as astronomers see it now, is a very restrictive one. And what we have traditionally called our universe is one of many.
If there are other universes, their laws of nature could all be set differently in their own Big Bangs.
If there had been many Big Bangs, and if, and this is the second assumption, the outcome of those Big Bangs were universes governed by different physical laws, then we could imagine that there would be one universe governed by any particular law we care to envisage. And therefore, it would not be at all surprising if there should be one universe that was tuned.
If our laws of nature are only one set of values amongst a limitless possibility of others, then the fine-tuning of our universe once again falls within the laws of chance. Our law of gravity would be but one of trillions of different values for gravity. The same goes for the cosmic constant, for atomic charge, even the numbers of dimensions. Suddenly, amongst all the many possibilities, it's not so surprising that at least one possesses the precise set of laws that allow human beings to evolve.
If you go into a clothes shop and there's a large stock, you're not surprised to find one suit that fits. Whereas if there's only one suit, you are surprised. So many universes governed by different laws would remove any reason for surprise at the apparent fine-tuning in our universe.
With one mighty intellectual bound, cosmologists could once again happily accept that our universe suited our existence precisely, without the need for a fine-tuner, a creator. Martin Rees coined a new word to describe the idea.
If it turns out that there's more to reality than just our Big Bang, or the aftermath of our Big Bang, then we have to either redefine our universe or use another word, and I've chosen the word multiverse to describe this whole ensemble of Big Bangs, this whole ensemble of universes.
The concept of the multiverse saves the scientific universe at a stroke.
We now have a natural mechanism to explain why there is all this diversity out there, which in turn eliminates the need for the fine-tuning that some people might have liked because it would say that there was a fine-tuner. We don't need a fine-tuner.
Yet theoretically, these other universes will always be beyond the scope of our telescopes. So is the multiverse really a scientific solution?
One thing which people often object to when confronted with the whole multiverse idea is they're saying this can't be science, talking about all these things you can't see. If I have a theory involving entities that I can never touch, never measure, never observe, that's not science then, is it? And I'd say quite to the contrary. What makes good science is not whether you can see it or not, but whether you can rule out the theory or not.
Having raised the possibility of other universes, cosmologists started to wonder what they might be like. And as they wondered, they found logic had set another trap. The multiverse idea had set them on a path that led them back, once again, to a creator. To avoid the conclusion that an intelligent force had had a hand in our creation, cosmologists invoked the principle of multiple universes. But what potential might those other universes hold for the evolution of complexity?
We have no idea how much variety other universes might display, and since we have no contact with them, all we can say is that there must be certain potential for complexity in those universes. It's easy to imagine universes that would be less propitious for life than ours, but of course we may not be in the optimum universe in a sense. We can imagine universes that might be more propitious. These of course will be potentialities far beyond the powers of our brains to conceive, but we can't assume in this grander cosmos that there couldn't be other universes displaying more complexity than ours.
Although we are completely cut off from these other universes, it's not impossible that one day we might be able to prove their existence.